This is the Behavior Change Project by Caroline Kester-Haney, Sabrina Liebig, Natalie Schilling, Leah Wilbert, and Giselle Tamayo. I'm first going to discuss the literature review. Precision teaching was created in the early 1970s. It was created on a basis of assessing the effectiveness of teaching methods, using rate of response as a guide. PT uses accuracy and speed as its unit of measurements. The precision teaching strategy used in this paper is say all fast, minute every day shuffled, SAFMEDS. SAFMEDS is comparable to flashcards, but there are several differences. One difference is that all materials are to be studied by the learner, not just what is currently being learned. SAFMEDS methods are also more structured. Research has shown that SAFMEDS is an effective strategy to help students of all ages, from elementary school to graduate school, study different concepts. Since SAFMEDS was created, researchers have been studying the use of this method to increase performance and extend learning outcomes. A review of different SAFMEDS studies indicated that SAFMEDS can increase fluent performance across different subjects. SAFMEDS are used to build repertoires in intraverbals and text as well. A study conducted by Stockwell and Eshelman applied SAFMEDS to increase fluency in Skinner's verbal behavior terms with a doctoral student. Over the course of 3 weeks, the student was able to meet the researcher's goal of answering 40 terms correctly in 1 minute, and 2 or less incorrect. Prior to the intervention, the participant answered 16 correct and 2 incorrect. So the data in the study showed a favorable pattern for the effectiveness of SAFMEDS over a period of time. A study conducted by Eshelman used SAFMEDS on acquisition of terms in undergraduate students. The participants were able to select the subjects of their choice. Each week, the participants met with researchers to be presented and quizzed on SAFMED cards. Eshelman, the researcher, reported that all students showed an increase in fact-based knowledge. The SAFMED procedure has shown to be a cost-effective way to increase verbal fluency across a variety of topics. Now Sabrina is going to present the purpose of our study.
The purpose of our project was a replication of the study from Kubina, Urich, Durica, and Haley in 2015. The study was called Developing Behavior Fluency with Movement Cycles Using SAFMEDS. The experimental question was, does SAFMEDS improve fluent identification of movement cycles among behavior analysts and special education teachers? Furthermore, the experimenters researched the maintenance outcomes of using SAFMEDS. The hypothesis was, when describing behavior, movement cycles can improve the verbal repertoires of those conducting interventions using applied behavior analysis theories and methods. Participants were 5 graduate students of class 611, section 805 at Ball State University. 4 students' first language is English, and 1 student's first language is German. The materials consist of SAFMEDS cards. Side 1 of the card is an image of an action with card number for better identification. Side 2 of the card is a verb-noun combination describing action, the movement cycle label. Images include different individuals of all ages and ethnic backgrounds, some cartoons and some real-life images. The images depict daily care routines, for example, brushes teeth, academic behavior, for example, cuts paper, leisure activities, for example, catches ball, and functional routines, for example, drives car. Here you can see an example of a SAFMED card. Side 1 depicts a picture of an action, and side 2 the movement cycle label. The images were taken from Quizlet.com and printed by each student from a common PDF file and on regular paper. 100 images were separated in Deck A and Deck B. The behavior definition was labeling SAFMEDS cards correctly. This is defined as a person using a verbal response to describe the activity depicted on a photo with a verb-noun combination existing of an action verb in present tense plus as and object, for example, drinks milk. The verbal response has to have a one-to-one correspondence with the definition on the backside of the card. Labeling SafMeds cards incorrectly consists of not matching the definition on the back of the card precisely.
The data collection was done. We sorted correct and incorrect responses. They were tallied after each trial and recorded at the end of each session on a shared tally sheet in Google Docs using Google Drive. Daily frequency data was then put into an Excel spreadsheet as correct or incorrect responses to the SafMeds cards for each participant, which was also shared via Google Drive. IOA was then done by another experimenter at a later time by watching the video recording on YouTube.
So now I present more on baseline. Participants administered their own trials during pre-test and baseline phase of the experiment. The pre-test was deck A and deck B and were taken before baseline phase. The participants attempted to name as many cards as possible within 20 seconds. They were not given access to what the correct answer is, which will be written on the back of the card, and no feedback is given to the participants. Results of the pretest was the first data point for baseline phase. The pretest was video recorded and then reviewed by another team member to see if their responses were correct. Baseline phase started with deck A and then alternate decks daily. Baseline phase was conducted of 20-second trial daily for 4 consecutive days. First participant to achieve 10 correct answers within 20 seconds started the intervention phase. The remaining group member joined when they have achieved 10 correct answers in 20 seconds for at least 4 consecutive days. A video example is given for your interest. The SafMeds intervention were conducted of daily frequency building practice with SafMeds, rotation between the counterbalanced decks A and B. The students split into 2 groups and interchanged roles of experimenter and participants. One student took IOA. The intervention steps were, for the trials 1 to 4, 20 seconds each. Presenter separated cards into 2 piles based on the correct or incorrect answer of the participant. Trial 1 to 3 were conducted also with 20 seconds ended. The incorrect pile was reviewed for 1 minute. When the minute was up, the cards were shuffled, combining the incorrect and correct piles back into one deck. Trial 4, the last one, was a test. The incorrect pile was not reviewed and the results depicted on the graph. All trials were again video recorded and reviewed by team member for correctness and inter-observer accuracy. 10 sessions intervention. The intervention phase took 10 sessions. Another video example is given for your interest.
For our results, the first figure, figure 1, illustrates the rates of cards identification by all 5 subjects in group EST1 during the baseline phase. BS stands for baseline session. The subjects moved to the intervention phase after reaching the goal of 10 correct answers in 20 seconds for 4 consecutive sessions. The range of total cards identified was 6 to 16. The average of total cards identified was 10.68. We then moved to subject 1, which was myself, Caroline. This illustrates the complete data set for all of my trials for the baseline and the intervention. The total range of cards was 6 to 16, and the average of total cards identified was 7.92. And this illustrates the complete data set for subject 2, Giselle, of group EST1. Again, baseline session is the BS, intervention session is the IS, and T stands for trial. The range of total cards identified was 5 to 12. The average of total cards identified was 9.12. Figure 4 illustrates the complete data set for 3, Leah, of group EST1. Her total range of cards identified was 5 to 15, and the average of total cards identified was 7.87. Figure 5 illustrates the complete data set for subject 4, Natalie, of group EST1. Her total range of cards identified was 6 to 14, and the average of total cards identified was 9.27. This is the results sheet table that we have. It has the baseline for all 5 participants. You can see from this slide that we had varying degrees of numbers of baseline sessions that it took us to be able to advance into the intervention. Both Leah and Natalie had 5, I had 9, Giselle had 10, and Sabrina had 12. This is the continuation of that table that divides the answers into correct and incorrect for the intervention sessions, and has them also divided by trials, 1, 2, 3, and the test, which is actually what we used for our variable, discriminative variable. This is a continuation of those numbers. The total range of cards identified for the baseline was 6 to 16. For the intervention, that was 5 to 12. The average cards identified for baseline was 10.68, and the average of total cards identified for the intervention was 8.04. So you can see the same abbreviations in this chart as in the other graphs. Overall, the baseline results netted a higher initial levels of cards identified in 20 seconds in the baseline phase, with an average of 10.68 versus an average of 8.04 cards identified in 20 seconds in the intervention phase. However, we feel that this discrepancy can be qualified by the different procedures used in the different phases. Once in the intervention phase, each participant increased the number of cards identified in 20 seconds over a period of 10 sessions, while decreasing the number of incorrect answers. These numbers mean that the overall participants improved 22.82% in correctly identified cards in 20 seconds between the first 5 sessions of the interval trials and the second 5 sessions of the interval trials. They also decreased their numbers of incorrectly identified cards in 20 seconds by 80.72% between the first 5 sessions of intervention trials and the second 5 sessions of intervention trials. Giselle?
So I will be going over the IOA. The way we were able to calculate IOA was by taking the smaller number, dividing that by the larger number, and multiplying that by 100. And then we took the number of intervals at 100, divided by the total intervals, and multiplied that as well by 100. The IOA score for the replication was 73.13%. Treatment fidelity was increased by recording all of our recording all of our sessions. This ensured that each variable was accurate in each session, allowing the session to then become the true value. Integrity data was collected on each of the following measures, which we had correct materials being used, proper positioning of participant, distraction-free environment, correct number of SAFMEDS trials implemented, minimum level of daily sessions per week of the SAFMEDS intervention, video recording of the assessment trial. Each score was checked against the video recorded sessions. We used YouTube using Google Hangouts on Air. This ensured accuracy in recording and fidelity of implementation. The mean integrity, procedural integrity was calculated by dividing the number of steps correctly completed by the total number of possible steps and multiplying that by 100. And our procedural integrity was 100%. Now Leah will be presenting the limitations.
I will be going over 7 limitations within the study. The first limitation to the replication project was the results of the study differed from those of the original study by Kubina in 2016 because the experiment using the SAFMEDS flashcards took place over the computer instead of in person due to our locations. The participants in the study had an experimenter who was able to set a timer, flip the cards, and put the correct and incorrect flashcards into the right piles. However, it was found difficult for us as participants to do all of these tasks and flip the cards in a timely enough manner to meet the criteria to move on to the next phase, from baseline to intervention and from graduate from intervention. To meet the criteria to move forward from the baseline phase, a participant had to have at least 10 correct responses in 20 seconds in each of the 3 trials and the test, the dependent variable trial, for 4 consecutive days with less than 1 incorrect response. Then, to meet the criteria for graduation from the intervention phase, each participant had to have 17 correct responses in 20 seconds in each trial and the test for 3 consecutive days with less than 1 correct response. As stated in the above response, it was found to be impossible in the time that was allowed to meet the criteria from the intervention phase. Now, the next limitation to the project was that, unlike the original study, the video recorded baseline was done as individuals. Then we realized for a more accurate and valid replication, we would have to perform it in pairs. It was arranged to do so for this intervention phase. One of the group members who lives in Germany, we made arrangements that she would be designated as IOA person for all trials, the presenter of the cards being the first. The third limitation was results-based. As the results showed, the baseline phase generally produced higher amounts of cards answered in 20 seconds than were answered in the intervention phase. The group is unsure how it was possible for the original presenters to achieve such results published in the allotted time span. Perhaps it was done with technology such as computer program or an iPad app. The fourth limitation was the fabrication and the manufacture of the flashcards used. And each group member printed and created their own flashcards from a shared PDF file. Some group members printed bigger cards, some printed smaller cards, and at times it was difficult to see certain cards via the phone or the web that we used. That is, the cards looked blurry at times. Sometimes they were not lined up properly for the camera. They were upside down. This caused the receiving participant to move on to the next card since they could not answer. Also, with the baseline phase, each group member was able to control the speed of their own cards being flipped. However, with the intervention phase, we relied on the other person that was presenting to the participant. The fifth limitation to the replication project was when working with group members, it is necessary to use technology such as Google Hangouts, phone, texting, and this causes several limitations in terms of direct replication. If all the participants and the researchers were able to be present in one physical space, the experimenter or the experiment could have been replicated with much higher fidelity. With the group's temporal limitations in different locations, it was hard to find other ways of replicating the experiment in such a way that would make it easier for everyone. Having a participant whose first language was not English and who lived in a foreign country from the rest of the group also posed issues not mentioned in the original study. This also made it very difficult to video record data as often as necessary with the different time zones. This limitation was overcome by removing her as a participant and leaving her as just an experimenter and designating her as the IOA. The sixth limitation was the standard acceleration chart. All of the group members had an issue with this chart and how to read this chart. The original experimenter chose to replicate because the group members all used flashcards and SAFMEDS programs such as Quizlet. The idea of fluency building through SAFMEDS flashcards, practice for our BCBA board exam, was an exciting one that our group wanted to further validate. The one component, though, the standard acceleration chart, that was unfamiliar was something that we hoped to learn how to use with guidance. It instead became one of our biggest issues. Perhaps we should have chosen an experiment that would not have challenged us to learn something new. And finally, our seventh limitation to the replication project was the verb-noun combinations that were used with the SAFMED cards. There were many actions that were comparable, and choosing the correct option is not always readily apparent, nor is it incorrect answers always wrong. So this is confusing for the participants on what was to say. For example, if the movement cycle depicts a man in front of a stove with pans, the participant could answer by saying makes dinner, but the correct answer is makes food. Also, using a verb ending in an S, noun combination, doesn't always make sense grammatically or in practice. For example, sleeps bed would be more of a difficult card in meaning to differentiate than drinks water. That is, you should say sleeps in bed, but the combination was only 2 words. This constraint made several routine movement cycles not eligible in the experiment. Sits chair, zippers bags, plates computer, and so forth. Now moving on to Giselle.
So to wrap up our presentation, we concluded that further research on this topic is encouraged. We also realized as a group, despite our unsuccessful attempts to reach a passing score, progress was made across all participants. This is showing that SAFMEDS is it's an effective way of increasing the correct answers. However, if this experiment will be replicated in the future, we do encourage that it should be explained more precisely and limitations be taken into account so that they can be prevented, and to increase treatment fidelity across different settings. Now we will go over a few of the references that were used in our literature review that we have referenced throughout the experiment. And that concludes our presentation, and we thank you for your time.